All right, so we are starting chapter 4 today, and chapter 4 is on systems of equations. That's just if you have more than one. Usually up to date, we've had just an equation we want to graph, y equals mx plus b, or y minus y1 equals m times x minus x1, and we're just graphing one line. Okay, but what if I have multiple lines, systems of them, usually two, systems of equations? Well, how do we solve those? What does that mean? So imagine if I have two different lines, okay, and I'll put them in two different colors so we can see what they are. I've got a line that goes, I don't know, from here down to here like that. There's a line. And then I've got another line that goes like this, from down here up through like that. Okay, so each of these lines represents an infinite number of solutions, right? This red line has whatever this point is right here. What is this? This is 10, negative 3. So 10, negative 3 would work if I put it into the equation. That's one possibility. But each of these points on this line represent a different possibility. There's an infinite number of them in this red line. And the blue equation represents this blue line represents an infinite number of possibilities for the blue line. Not only 10, 10, but looks like down here at 0, 4, or down here at negative 7, 0. Those are all other possibilities for the blue line. But there's only one point that actually works for the red line and the blue line together, and that's right here, this point right there. The place where this point right there, the place where these two intersect. That the intersection of the red line and the blue line is the one point, is the one value of xy that works for both the red value and the blue value. So that's the solution to this systems of equations. That would be the only point that works for both of them. And so our objectives today are to be able to graph two linear equations on the same plane. Well, you guys have learned how to graph one equation, so you just do one and you do it again. So if I have a blue equation and a red equation, great, I'll draw a blue line and a red line, no problem. Then you have to identify the point where they intersect. That should be pretty obvious. In this case, it's right here. What is that point? And so in this case, we would say that, okay, that these points intersect at looks like 3, 6. And so the one place that works for both the red line and the blue line is 3, 6. That's our solution to the systems of equations. And then finally, sometimes you have a system that looks like this. So I'm going to get rid of this one to start with. Okay, imagine if my blue line looked like this again. Here, I'll do a blue line like this. It goes from here to here. Oops, sorry, I was going to make a line. Okay, it goes from here to here like that. Okay, and imagine if my red line looked like this. It went from here to here. Okay. Well, in that case, these two equations, or the solutions to these two equations are parallel lines. They never intersect. So in that case, there would be 0 intersections. So what it says right here, how do you tell if it has, how do you tell if it has no intersections? Like this, if it has parallel lines, then you'd have no intersections. If it looks like this, I don't know, we'll draw one like this. Okay. Well, in that case, there is one intersection, and it's right there. And then sometimes you have the blue line looks like that, and the red line looks like this. I'll draw it like right here. And it turns out they're the same line. That actually, when you graph them, it turns out that the red line and the blue line are actually the same line, in which case, in this case, there would be an infinite number of solutions. It's just this red line. Well, at the moment, I put the red line over the blue line, but it's the red line and the blue line together, that they're on top of each other. There's an infinite number of solutions. Negative 10, negative 10, negative 9, negative 9, 0, 0, 10, 10, whatever. There's an infinite number of solutions. And so those are the only possibilities. If they are the same line, it's an infinite number of solutions. If they are a line that intersect, then there's only one solution. And if they are lines that are parallel with each other like this, then there are no solutions. And so we're going to do some example problems where you are going to just graph the two lines and then try to figure out, well, are they on top of each other with an infinite number of solutions? Are they parallel with zero solutions? Or do they intersect, like, for example, this one? And if they do intersect, then where? That's the answer to our solution. Where do they intersect there? That's the point. That would be our answer to our system of equations.